In this video, we'll look at how to find the inverse of a matrix using MATLAB. So let's start a new section here, call this inverses, and we'll get rid of all the stuff we have going on. Alright, so what is an inverse? In algebra, we say 1/5 is the inverse of 5. It's the multiplicative inverse, or the reciprocal, because when we multiply 1/5 times 5, we get 1. And 1 is called the identity. Multiplicative identity. There's also an additive identity, which is called 0. So matrices have inverses too. Things that you can multiply together to get the equivalent of 1. What is the equivalent of the 1, though? It's called an identity matrix. So an identity matrix is all zeros except it has ones along the diagonal. All zeros except it has ones along the diagonal of the matrix. Let's make one real quick. So 1, 0, 0, 1. When I run this section, it's all zeros except for along the diagonal here I have ones. Okay, you just get the idea. So the reason why this is called the identity is because if I have, let's go back and grab another 2x2 matrix. If I have a matrix G, let's go ahead and see that, and then we'll see what G times ID is. So run this section. G is 3, -4, 5, and 2. 3, -4, 5, and 2 is the result when I multiply by the identity matrix. That's important. That means that you can multiply by it without changing the value, just like 1 in scalar algebra. Right? You can multiply both sides of an equation by 1, and it's still an equation. Notice that in matrix multiplication, multiplying on the left is different than multiplying on the right. It's not commutative. We saw that because the sizes have to match up, but it's also true for 2x2 matrices or any square matrices. Multiplying by the left is different than multiplying on the right. When I run this section one more time, I get the same thing though, because again, multiplying by the identity matrix does not change the value of a matrix, whether it's on the left or right. So multiplying by identity matrix doesn't affect value of G, whether it's on the left or right. So that's why it's called the identity matrix. And now we can talk about what a multiplicative inverse is, or matrix inverse. It's the matrix that when I multiply it by my matrix, I get the identity matrix. So let's write this down. The inverse of a matrix A, let's call it matrix A, is not 1 over A, because you can't actually divide 1 by a matrix. That's not a matrix multiplication thing. But rather, a matrix we'll call A exponent -1. Let's make that shorter, right? A to the -1 power. That's our name for the inverse, with the following property. When you multiply A times A to the -1, you should get identity matrix. And when you multiply on the left times A, you should get identity matrix. These are not MATLAB code, so let's comment that out. So maybe properties is a better. It has to work in both directions. And all right. So how can we make use of this? By the way, let me mention real quick that not all matrices have inverses, unlike scalar numbers and multiplication. Sometimes there isn't one, and when that happens, the matrix is called singular. I don't know, we won't need that. And also has a determinant of 0. So if those things sound familiar to you, great. If not, let's take a quick because MATLAB will find determinants too. So let's take a quick detour into determinant land and say, what is a determinant? Each matrix has a number associated with it called a determinant that tells us, well, among other things, whether there is an inverse. If determinant equals 0, then no inverse. So the command in MATLAB is just DET, which is why it's a common abbreviation. Let's use this, or vice versa. It's not because it's a common, anyway. That's the name of it. Let's make a matrix D called, let's just do 1, 2, 3, and 4. See if this one has an inverse. If so, then the determinant will be 0. Those are if and only if relationships. Let's call it my determinant, and it will be det of D. I want to see it in the command window, so let's leave that semicolon off. I get a -2. Cool. It's not 0. That's what I care about. So there's an algebraic way to calculate it that we're not going to worry about. Let's create an inverse. Here's how we can create an inverse in MATLAB. And I'm going to call mine inverse D. D to the -1 power. I know this will not produce an error because I already checked the determinant and it's not 0. So run this section. It's given me the inverse here, and now what I want to see is what's D times D to the -1. Oh, I called it inverse D. What's D times inverse D? The identity matrix. It's all zeros except for those ones along the diagonal. And let's also check inverse D times D. Run section. Again, now we have 2 of them. Zeros except along the diagonal. All right. So we'll do some more examples with matrices and their inverses and why it's useful in another video. But for now, you now can calculate inverses using MATLAB. See you next time.